All right, Unit 2, expressions and equations. And not necessarily this first set of notes, but this unit in general is probably one of my favorites. When we get to solving equations, it's something that, number one, you're going to be using in every math class from here on out. But it's also, I think it's fun to teach. So I enjoy it. Expressions and equations. Alright, so we have a few vocabulary words on this one. These first few units are full of vocabulary. Then once we get to where we're really doing a lot of solving and things like that, we don't have near as much vocabulary. But you'll know Unit 1 had a ton of it. This one, first thing we're going to talk about is a variable. Variable. A variable is anything that holds the place of a number. Anything that holds the place of a number. And variables are where a lot of students struggle because all of a sudden now there's letters in your math, right? And it kind of stresses you out a little bit because these letters and you're used to numbers and all this kind of stuff. But I want you to think back to maybe first, second, third grade, somewhere in there. Joe, remember the problems that look like this?
Yes.
Weren't those great? I just wish we did those still. The cool thing is we still do. That box, what goes in the box?
The answer.
And what would the answer be to this one?
2.
2. So in this one it would be 3 plus 2 would go in the box equals 5. Now instead of a box, it's just going to look like this.
That makes it
So-
looks like a problem.
So what would go in for x?
2.
2. It's still 2. It's just something else. If it stresses you out that it's a letter and you want it to be something different, make it something different. I don't care. It could even be that, and it would still be
2.
2. It doesn't change, okay? That's a variable. The box is a variable. The x is a variable. The happy face is a variable. If you draw a picture of SpongeBob, it's a variable. I don't care what you use, okay?
Do we write this example?
So yeah, it doesn't matter what you use. It's a variable. Now, the reason we don't do boxes still is because in some problems we need more than one, and then it gets real confusing about boxes and circles and what if you need 3, and then what do you draw for the third one? Is it a triangle? And you know, all that kind of stuff. So they use the letters because pretty much everybody recognizes the letters, and everybody knows how to draw an X. So my box may look different than your box, but our X's are going to look pretty close to the same thing. My star, like if I had to do a shape of a star, stars, everybody's stars looks a little bit different when they're trying to draw it. So they like to do the letters because everybody recognizes letters, and you can use more of them at once if you want. We're not going to use that many. So the most we'll ever do in our class this whole year is 2 different variables. That's the most. But that's all a variable is. Just something that's hanging out, waiting for you to tell it what number goes there. It wants you to figure out what number goes there. Okay, an expression. Y'all know how an expression in English, like in English class, an expression is something that's just like a short little phrase. It's not the whole sentence, right? Like, I'm trying to think of a good expression. Like, how are you doing? Or, what's some expressions that we use? What? What's up? Like, that's an expression. It's not really the whole sentence thing. It's just something that we use, like it's raining cats and dogs or something crazy like that. They're just expressions. An expression in math is like a short little part of an equation. So it's a group of variables and numbers that represent words. It's part of an equation. In math, an an equation is like the sentence. And the expression is part of the sentence, not the whole thing. It's part of an equation, which means there's no equal sign. For example, an expression could be something like 4 plus the box, but no equal sign, just 4 plus the box. Or 10 minus x. Those are expressions. So if we know what an expression is, we need to know what an equation is. An equation is an expression that equals something. So if I'm using the same examples for my expression, it could be 4 plus the box equals 6. That's an equation. Or 10 minus x equals 3. That's also an equation because it has an equal sign. Hopefully those two are both very easy and you can figure out what the number is that goes in for the variable. 2 and then 7. Yep. Y'all have been doing algebra for a really long time, but back then it would have blown your minds if they'd have told you that. So they would have never said, hey, you're doing algebra and you're solving equations. And they just said we're doing fact families. Do y'all remember those? Yeah, they just called it fact families back then. It's the same thing. Same thing. Okay, you're going to need this little part at the top of your notes that says keywords for writing expressions. And it has addition, subtraction, multiplication, division. Just that little line. Not the things under it yet. Just move this down. Get that little strip glued down. And we're going to talk about just some keywords in word problems that tell you that it's addition, subtraction, multiplication, or division. And there's lots of different words. You guys have known a lot of these for a long time. Some of them we used way back when we were doing fact families. And some of them we've used, throughout the years. So what did you call addition back when you first learned? Add, okay. What else?
Subtract.
Subtract.
Multiply. Divide.
So those are the easy, obvious ones. Add, subtract, multiply, divide. Okay. When you were doing those little, y'all remember those colored teddy bears that you had to do in kindergarten? You do this, this and this. What did y'all say when you were putting them all together? 2 and 3. What would go in the middle? Plus. Okay. So plus 2 plus 3. That's kind of, plus is a word that means add.
Minus.
Minus is a word that means subtract.
Times.
Times. These are like the ones that we used to say. And then divide was still the same thing that we used to do, right? We still said divide. What else? How about the math word was called sum? Do y'all remember that?
Yeah.
The sum of things. Addition, we're gonna leave add. Addition's right here. So sum and then difference. You remember your teacher saying find the difference?
Multiply means each.
Each. Of is a good multiply word. Any divide words y'all can think of? We did divide. What did you say? Like to divide by. Yeah, a lot of times it would have divide by. Quotient is the mathematic word that your math teacher probably used, was quotient. Find the quotient.
Fractionize.
No.
Fractionize. A fraction would be divide. I don't know that I've ever said to fractionize anything, but fraction would be not decimal, but like if you say to split.
No.
Y'all remember that?
I never did.
Sometimes, yes, sometimes each could work for division too, because like if you're saying each person gets a certain amount out of the whole, then that's splitting it up. So yeah, each could kind of go here too. So this one's kind of a possibility here, possibility here. What about, let's look at just add.
Wait. What does it say for division on the third row?
Fraction. Division, quotient, fraction. Let's look at just the addition ones. What other things are addition? Total, maybe?
Yep.
All together? Or if you say so-and-so has 12 more than somebody else, then you're adding
More than
12.
less than.
More than is addition. Okay, that's good for addition. What about subtraction? Let's see if we can add a few to subtraction.
Subtraction less than.
Less than. Takeaway. Do y'all remember doing takeaways?
Yes.
Calling it that. Subtracted from. It's a special one, so I want to make sure you have that one written down. Subtracted from. Okay, multiplication. We have multiply, times, each of, the math word is product. To find the product of two numbers is to multiply. And then there's some special ones that are multiply, like twice, or double, or triple. Okay, so there's special words, yes. Any of those special words like that mean you're multiplying by a certain number. So like twice would be multiplied by 2. Or double would be multiplied by 2, or something like that. So there's a group of special words for multiplication. There's also for division, if you said a fourth, or half, or something like that. There's special words here. Split and equal parts is a division one. Equal parts. That's good. That's a good list. Okay, what I want you guys to do, if you have another color pen or something, or if not, it's okay. There's two of these I really need you to look at. Less than and subtracted from. These two are special. If you have just a highlighter and want to highlight them, or just put a star beside them, or whatever you want to do. These two are special. These are what I call switches. Not the kind of switches that your grandma used to get off the tree, but different kind of switch, not that kind of switch. Okay, so these I call switches. And the reason I call them switches is because when you see them in a word problem, you've got to switch the two numbers the opposite than what they gave them to you. For instance, if I say 10 minus 7, I would just do 10 minus 7 and get 3, right? 10 would come first, 7 would come second. Does that make sense? 10 minus 7. Minus is not a switch. But if I say 10, let's do 3 less than 5. Would I do 3 minus 5 or 5 minus 3? If it's 3 less than 5, what's the number going to be? 5 minus 3, which is 2. So I'm going to have to switch the order of this number and this number. Even though 3 is the first word and 5 is the last word, when I do my problem in math, I'm going to have to switch them.
So,
Do y'all see that?
So the only time that you switch it is if it's
one-
subtracted from or less than.
Yes, if you see those two phrases, that's the only time you have to switch them. Okay, the other one would be like 2 subtracted from 6. In my phrase, 2 comes first and 6 comes last, but 2 minus 6 will not give me the right answer, because that would be negative 4. So I need to do 6 minus 2 and get positive 4. Those are the only two that are switches, and I just did the first one to show you that not all of them are switches. Any questions on those, on switches? Okay, flip the page and go ahead and cut out A through I, this little list of expressions. We're going to glue it down at the top. And I'm going to go ahead and cut out what you're going to need for this whole page. If you're a quick scissor person, you can get yours set up too. If not, that's okay, but you'll kind of come in next.
Which one do we cut out to?
The next one's going to be the A through D, the 2 times a number plus 5. You just leave a little space between the two of them. So you're going to have that one on this page, you're going to have the A through D, and then the track 1 media word problem is going to go at the very bottom. That's going to fill up that page. You can get that all glued down and have that page set up, and then you don't have to worry about it. Okay, so let's look at the top. If you're not quite ready, it's okay. I won't write anything yet. If you want to, at the very top of your page, write down those 2 special ones, the 2 that are switches. Just to remind you, if you see those 2, you're going to have to switch the order. So what were they? Subtracted from and less than. So you might want to write those at the top. It's just the track 1 media at the bottom. The little word problem. Subtracted from and less than. Those are your 2 special ones. So what I want to do when I read these, when we read these expressions, is I want you to circle the keyword that tells you whether it's addition, subtraction, multiplication, division. We're going to circle the keyword. We're going to underline the number words. Okay? And in this one, it's telling us what letter we have to use for our variable. So on your homework, you get to pick. If you want to use this smiley face for the variable, you can. If you want to use whatever, it doesn't matter to me. If you want to use your initial, you can use your initials. You can use any letter, any shape, anything you're wanting to hold the spot. What? Okay, 30-minute drawing for your variable. You're going to be writing a lot of those. Okay, so yeah, don't make it anything too complicated. No Mona Lisas or anything like that. All right. So 7 more than a number n. So our keyword is more than. So circle that. And the number is 7. So 7 more than n. What's that going to look like? It's more than telling us to do what?
So 7 plus
7 plus n. Now you guys know that if I add, I can flip it and it's okay. I could do n plus 7 and it'd be the same thing because it's addition. 7 plus 1 and 1 plus 7, isn't that the same? So if you switch this one, I'm not going to count off because addition's not going to matter. Subtraction matters. If you switch it, it ends up changing it to a negative answer usually. Okay, the next one, the difference, so the word difference, of a number n and 7.
And minus 7.
So the difference of a number n and 7. So this is n comes first, minus 7. You do it in the order they give it to you unless it's a switch. N was first, 7 was last.
Subtract it from the lesson.
Yes, I just put those at the top to remind me that those are the special ones. C says the product of 7 and a number n. Which one? What's my keyword here? Product, which means to multiply, and we're doing 7 and n. Now in algebra, here's how you're going to show multiplication. If it's a letter, you just write 7 and n right beside it. You don't need the dot. You definitely don't want to put the x because what is that going to look like?
Times.
Well, x for y'all has up until now has looked like times, but now it's going to look like a variable. So don't put the x because that messes everything out. It looks like you have two variables. And you could put parentheses, but there's really no need to. You can just smash them together. 7 times n goes together, 7n. Okay, D is the quotient of a number n. So n comes first, and 7. Now when you divide, we did a little bit of this with our integers. It's going to look like a fraction. I don't think I can fit it over there. So n over 7, like that. Y'all don't have to put your little line across your 7 like I do. It's just a habit. I just do that so that you know the difference between a 1 and a 7 when I write it. I don't know. It's something math people do. It's just, you don't have to do that. But n over 7 is the same as divide. Do not use the little divide sign with the 2 dots. That's old school, that's elementary. We're not using that anymore. Okay, so make it look like a fraction. All right, letter E says the quotient of 4.2. So this one's division again. 4.2 comes first. So I still don't think I can fit it. Maybe I can. 4.2, nope. Over C. I can't fit it on that little B line. 4.2 over C.
I can fit it on there.
I can't write that little. I write too big. Okay, letter F. A number T minus 15. So minus is our clue word. Is that a switch? Because I know our clue word, our switches are both subtraction. Is that a switch? No, that's not one of them. So it's going to be T minus 15.
Next one's a switch.
Okay, awesome. T minus 15, and they've already started for us, so we don't have to worry about it, huh? Letter G, 5 less than a number x. So less than is our keyword. We're subtracting. Since that's a switch, what do I do? X comes first, 5 comes last. So x minus 5. Instead of 5 minus x. Just switch it. And I don't know why I give them mark that will start up. Letter H, 12 subtracted from a number B. So here's the clue words. Subtracted from is a switch. So 12 has to come last and B needs to come first now, right? They've got to switch places. So it's B minus 12. The letter I had a star beside it, but it doesn't really need one, so you can mark the star out. Because in adding, it doesn't matter if you switch it. It doesn't change your answer, so, I mean, you can switch it if you want. A number n added to 10, so n plus 10. Okay, so you're just writing the expression. You don't have to solve anything, you don't have to figure out what the number is or anything like that right now. You're just writing it out. And on your homework, that's what it's going to look like. Okay, on these next four, we get to pick what we want our variable to be. If it doesn't tell you, then you need to tell me. So it's let blank equal the number. And you put in the blank whatever it is you're going to use for your variable. If it's a star, put a star there. If it's your initial, put your initial there. I suggest you don't use T very often because it looks like a plus sign. S tends to look like a 5. Z, some people write their Z's like a 2, or their 2's like a Z. So those are about the only ones that I would worry about. What else? Lowercase b sometimes looks like a 6. So just pick, if you want to pick a letter that's your initial, or I don't know, the person you're in love with, or whatever, or you like a symbol, then pick a symbol, like a happy face, or a star, or a box, or whatever. I'm going to use X, because I like X.
Can we use 2 letters?
No, you can only use one letter. Okay, so on letter A, it says 2 times a number plus 5. So we've got a couple things going on here. We've got times and plus, right? We've got to worry about a couple things. So I've got 2 times the number plus 5. What does multiplying look like in algebra? They're just stuck together, right? So it's just a 2 stuck together with a letter or a variable, whatever you're using. So this is going to be 2 times the x, the number, or whatever letter you're using, and then plus 5. Plus 5. Does that make sense? Like it's just 2 times the number plus 5. We're just writing it in algebra based on the words they're giving us. Okay, the next one says 7 less than 3 times a number. Okay, this little part right here all goes together, and then this is its own little thing. So 3 times a number, what is that going to look like? I'm not going to write it yet, but what will it look like for me, since I'm using X? 3x. It's just going to be a 3 and an X stuck together, right? This is just a 7. So if this isn't a 7, and this is a 3x, and that less than, what do I know about that? It's a switch. This is a switch. I've got to flip-flop the 3x and the 7. Okay, those two have to switch because less than is a switch. So it's going to be 3x minus 7 because less than is a switch. Letter C, 9 less than a number. 9 less than a number. What do you know about less than?
It's a switch.
It's a switch. So the 9 and the number need to flip-flop. So this needs to look like x minus 9. And then the last one is another one that has 2 things going on in it. It has the sum of twice a number and 31. Remember what twice means? What does twice mean? Times what?
2.
Times 2. So it's a special one. It means multiply, but it means multiply by a specific number. So times 2. So this is like 2 times the number x, or whatever variable you're using, and then 31. So what's that going to look like when I write it out?
2x plus 31.
There we go. 2x plus 31. Okay, I want you guys to read the word problem and look at your choices down here This was supposed to be choice A, but I don't know what happened to A. So A, B, C, or D. I want you to look at your choices and see which one you think it is before I go over it. Y'all try to pick the one you think it is. It says Track One Media sells all CDs for $12 each. Now remember, each could be a couple, it could either be multiplying or dividing depending on how it's used. If you're continually adding more of them, that's multiplying. If you're splitting something up and each person gets a certain amount, that's dividing. So which one is this one?
Multiply.
This one's multiplying. Okay, which equation best represents the cost C of a given number of NCDs? Okay, this little part right here, when it says best represents the cost, that means that letter gets to be all by itself. I need C all by itself on one side of the equals. Okay, if it ever says if it's representing something specific, that's the thing that's by itself. So that automatically helps me get rid of two of these. Which two can I mark out because they don't have C by itself?
A and C.
A is gone.
C.
C is gone. This one has C by itself, this one has C by itself, right? Okay, this one's adding 12, this one's multiplying 12, and what did y'all say it was?
D.
Multiplying, so it's gonna be D. That's all you're doing, is just picking out which one makes the most sense. Okay, you're gonna need the box of properties first, and then those extra little examples. And they can all just be cut out on together. Let me show you. This. And then this. The last thing we're going over today is properties. So cut out that box where it has the properties, and then these are left from the first page. They're at the very bottom of that first page. Just cut them all out together and glue them down. We have 3 properties that we've got to cover for algebra. And one of these we use a lot. The other 2 we use, but you don't really notice that you're using them when you use them. The distributive you'll end up using a lot, and we'll talk about distributing things a lot. But these are your 3. You have commutative. It doesn't have an N in it, so it's commutative, associative, and distributive are the 3 that we're going to be using. And I'm going to give you some ways to help you remember which one's which and what they mean, because on your test for this unit, on your assignments for this unit, and on your STAR testing, they're going to ask you questions like, which property are you using? And you have to know which one's which. So commutative, the root word for commutative is commute. Anybody in here know what a commute is? Your parents commute. What is a commute?
Communicate.
No, that's communicate. That's with an N. No, that's with an N. That's communicate.
Isn't it
Commute.
like an argument?
No.
It's like
It's like what?
It's like if you work in a different city and if you
commute. You probably hear it on the news in the morning, on the radio in the morning. If your parents work in Dallas, well, it really doesn't matter. They don't have to work in Dallas. But you'll hear them talk about the commute, and they drive back and forth, right? Or they ride the bus. They go up to the dark bus, and they ride the bus to Dallas or whatever. That's their commute. And they'll talk about how the commute was terrible this morning, or the commute was pretty easy today, or whatever. They're talking about the drive. Commute, the word commute, means to go back and forth. So it's like back and forth. So this is the back and forth property. Because if I drive from Dallas to Waxahachie, actually if I drive from Waxahachie to Dallas, and then turn around and drive from Dallas back to Waxahachie, it's essentially the same trip. It's just two different directions, right? Waxahachie to Dallas, and then Dallas to Waxahachie. It's the same exact trip, the same number of miles. They probably take the same exact pathway on the same exact roads, but they're just going one direction and then they come back the other direction. It's back and forth. So it's like this one goes this way and then this one turns around and goes this way. So look at your examples. A plus B equals B plus A. You'll see how it just flip-flop? It goes back and forth. So if you see it go back and forth, it's commuting. It's commutative. A times B and B times A. Which technically in algebra, they're going to write that as AB equals BA, and they're not going to put those little dots between them. Just so you kind of know. That's what they'll look like. Okay, so that's commutative property. So commutative back and forth. Think about parents driving to work, or you coming to school, or whatever. Associative. If I ask you, or well, first of all, the root word of associative is associate. If I ask you who your associates are, or who do you associate with, what is that?
Who do you talk to?
Who you talk to, who your friends are, who you hang out with, your group, right? That's your group of people. Like if you hear about like law firms, they have such and such an associates. That's the group for the law firm. Like that's their group. So associate means groups. And on these, the groups have to change. So the groups are changing. In other words, I have all the same players, A, B, and C, A, B, and C, but we grouped them a little differently. On this side, A and B are hanging out, and on this side, B and C are hanging out. Okay? They're still all the same players. Right? So like at lunch, A and B are sitting at lunch together, but there's not any room, so C has to sit by themselves. The next day, A shows up late, but B and C are already at the table. So it's the same exact thing, it's just grouped a little differently. So the groups are changing. A and B in the group here, B and C in the group there. So if the group changes, it's associative. If you switch the grouping around. Okay, this one, the root word is distribute. If I walked in and told somebody to distribute a stack of papers to the class, what am I asking them to do?
Yeah.
Pass it out. Should they give it to just some people?
All of them.
Everybody in the class should get a paper. If I have candy and I tell you guys I'm going to distribute candy to the class, which I don't, so don't get mad. But if I did, and I skipped you, wouldn't you be a little upset? Yes, everybody in the class gets candy if I say I'm distributing to the class. So distribute means to pass it out. And you'll hear me say, you got to pass that out. Like you'll hear me use those words a lot because that's what distributing is. Pass it out. This one has a hint because the parentheses will disappear. So you know it's this one if the parentheses disappear. Here's what happens. And since I wrote on that one, I'll do this one. This A in the front of the class, in front of the parentheses, gets passed out to everything inside. So now A is with the B and A is with the C. A is like the candy getting passed out to the class. The class is what's inside the parentheses. So A goes to the first thing, A goes to the second thing. If there was 3 things in there, A would go to the third thing. If there's 10 things in there, A goes to every single thing that's inside the parentheses. If it's not in the parentheses, that means that's like a person in ISS. They're not getting candy that day. Right? I'm not running down there to give it to them. Or they're absent. I'm not going to go knock on their door and say, I gave candy to the whole class. You missed out. Here's yours. I'm pretty nice, but I'm not that nice, okay? So they have to be in the class to get it passed out to them. Does that make sense to y'all? So that's distribute. So we're just gonna look at these examples and decide, is it commutative, is it associative, is it distributive? So on the first one, 9 plus 7 equals 7 plus 9. Which one is that?
Commutative.
Commutative, it's back and forth, right? It's the same two things, they're just switching spots. So this one's commutative, so put a C beside that. You don't have to write the whole word. Okay, what about the one right below it? And be careful. 3 plus 4 plus 7 equals 7 plus 3 plus 4. They're trying to trick you on this one.
Commute,
Okay, why do you say it's commutative?
because it's going back and forth.
It's going back and forth. Which one are they thinking you're going to pick? Associative, because they think you're going to pick it because it's a grouping. But did the group change? No, the group didn't change at all. It's still 3 and 4 inside the group. They just switched spots with the 7. This one's also commutative. 2 times 3 in parentheses times 5 equals 2 parentheses 3 times 5. The group changed. Here's 2 and 3, here's 3 and 5. So this is associative. 3 times 8 times 0 equals 3 times 8 times 0. That's still associative. The group changed. N times P equals P times N. Commutative. Just goes back and forth. D times 4 times 3 equals D times 4 times 3. What changed? The group changed. That's associative. Alright, big hint on the next one. What's this one? What was the big hint? The parentheses are gone. If they're gone, it has to be distributed. The 6 got passed out to the A and to the B. 6 times A, 6 times B. And when you pass out, you're multiplying. That's how, in math, how you pass that out. Okay, the next one. Negative 3 plus 4 plus 5 equals negative 3 plus 4 plus 5. That's associative. The group changed. The next one. Okay, what was your hint? Parentheses are gone, and here's what they did. 2 times 15 is 30. 2 times 4 is 8. So they passed it out, but they did a little bit of the math work. Instead of showing you that that 2 is still there, they went ahead and multiplied it. Okay, P plus Q plus R equals Q plus P plus R. Okay, this one's a little tricky because they switched it around and switched the group, right? So technically, this is associative and commutative. They switched it and they moved the group around. Yeah, they switched the order and they switched the group. Okay, so that's all your properties.